Hey guys, as some of y'all may know, yesterday we hit the 100 problem mark, so I thought I would do a video on like how doing 100 problems like changed me type of, I don't even know what I'm gonna name it yet, video, but so today we'll just go through like a visualizer and then like some points that have like popped up in my head like about about competitive programming in general, and I have some examples of what I'm gonna talk about. Um, Not really gonna be much code in this video, but yeah, as you can see, we've been doing this for 24 days. I think today will be day 23 in the series, or is it 24? I don't even remember. I guess I can check real quick. Yeah, today would be day 24. Although I didn't actually like make a video the first day. I just kind of did some problems, but yeah. So as you can see, we've done 1, 2, 3, 4 contests. Like at first we were getting 400, 200, or like yeah, basically 300, 200. 100 rating, so we're plateauing out a little bit as we go. We're getting less rating, which is to be expected. Um, I'm doing like I think the first contest I could only do like one problem. Um, the next few like maybe 2 or 3, and then last contest I did 3 problems. So yeah, and these aren't like hard contests. Like these are Div 3, Div 4s. This was Hello 2026, which not too sure what div it is. Maybe Div 2. Um, but yeah, I do expect myself to start like plateauing through like the 1,000 to 1,200 range. Um, just simply I like okay, so 100 problems. How did it change me? Um, like I don't think I've learned like much new stuff. If a good like explanation. I think what I've taken away the most from these first 100 problems is that I'm much better at like implementing stuff. And if you see like in the visualizer later, a big section of my solves are actually just implementation solves. And I can't tell you like which specific field I've improved the most at, simply because like even the harder problems, it like not like there's obviously been like connections between problems. Like I've had moments where like, oh, this problem is kind of similar to this one that I solved before, right? Type of moments, but like there's not really a classification between like kind of similar. There's obviously tags, but like sometimes you don't even like follow the tags, right? So I mean, I can talk about some of them, and I will later. That like I can talk about like the types of problems that I found to be like kind of troublesome or kind of recurring. Um, but if you're telling me like, oh, what did you improve in the first 100 problems, I would just say implementation. I'm definitely faster at implementation now. I have like a formula of what I should be like going through, kind of what I should be thinking about. And so implementation is one thing, and the other thing is just like general thinking, um, like trying a solution. If it doesn't work, just try something else. If you watched any of my other videos, like I would probably have a moment where I pull up a whiteboard and I'm like, okay, what conditions do I need to meet? Or like how many ways to go about this is there? What am I thinking of? And even if I need to get help on a problem, I would like probably have like 2 or 3 perspectives of like, oh, you can probably solve it like this, and but someone else will be saying, oh, this is a possible solution, and I'll try to like discover them myself. Like maybe I'll use a combination of their suggestions, or maybe I'll just follow one. But yeah, as far as rating goes, that's what I expect. I do expect that I'm around like 1,000 to 1,200 rated, not much further than that, because I do struggle with 1,200 rated problems. I've been struggling with those, like I can solve them, but it does take me a very long time. And if a problem takes me over 2 hours, it's hard to make a video on, right? Um, like recording a 2 hour video is already like tedious enough. So if you've been seeing me doing like easier problems on the videos, that's probably why. And I'm definitely more skewed towards easier problems in this first 100 problems. Moving forward, definitely want to change that skew, like move it on to like 1,100 to like 1,300 focus. I'm no longer going through the old spreadsheet that you've seen me like work through. I just think it has too many, like, it's too bloated. Like, it's hard to track data, and I can probably pull it up actually for those of y'all who don't know what I'm talking about. But there's this junior training sheet with like a ton of recommended problems. Here's the problem: like, it wants you to log your reading time, thinking time, coding time, and debug time. But the thing is, if you're spending time logging that, like you're like you're eating up extra time. That's like time you're not coding. Like if it takes me like a minute or 2 minutes to read, and then I go back look at my timer. Oh, 30 seconds has already passed after I logged it. So you're unintentionally adding a ton of time just logging the time. And that can really cut into like problems, like easy problems, like problem A, problem B in contests where you're just supposed to go fast, and then first, I don't even know what some of these columns mean. Like these were here like before I like even put anything in, and they put like 1 in there. I'm pretty sure this is supposed to be like an accepted work in progress or whatever, like kind of column. But there's that. Another annoying thing is sometimes like these things aren't like auto formatted. You have to go format it yourself. Annoying as fuck. The category, you have to go put it in yourself. If it has a ton, it just looks really weird. And some of them are formatted, some aren't. Annoying as fuck. Video solutions, they're cool and all, but they're not in English, some of them. And some of them are in like other languages that I don't really use, like Java. Like I'm familiar, but I use Python for my solves. So not that it doesn't help, but if it's in English, it probably doesn't help that much. Or if it's not in English, it probably doesn't help that much to me. So no longer using the spreadsheet. Instead, now I'm using the A2OJ roadmap. You've seen this in the last few videos. I like it a lot more, actually. Props to the one guy in the comments that recommended this. I should have listened to you like right from the start, because this is cool. This actually logs like the problems you do. So yeah, I'm definitely going to be working on this. We'll still have a few videos of working on like 800, 900 rated, but it's definitely a lot less. Like the tier 3 problems, level 3 problems are actually hard. And the level 2 problems are probably like around that 1,000 rated that we're looking for. So yeah. Now, I guess the next thing to talk about is probably just the visualizer. Like, what kinds of questions have I been doing? Like what difficulty, um, and like whatever else is on here. So, looks like I passed most of my submissions. And then I'll have like a good portion, like good fifth of my problems where I have a wrong answer. And then I'll have 10% of the time I'll TLE, and the rest of the time, 30% of the time, I'll run time error. So don't run in time error too much. If I do, it's probably like a Stack Overflow because I use recursion or something. But yeah. Okay, languages. Just all Python. Haven't really had a reason to use C++ yet, as I've stated before. And a lot of y'all have asked me in the comments, like, why are you using Python? Why aren't you using C++? And to that, I just answer the same thing. Well, two reasons. I'm a data engineer, so like in all my classes and stuff like that, we're using Python. So familiarity with Python is like more useful to me than C++ right now. Another reason, I haven't ran into a case where C++ would pass, but Python would fail. So is that doesn't really like give me the incentive to switch, and like personally, I believe Python is a much more readable language and than C++. So like I'd rather look at a Python script any day over C++. And I guess most solutions are in C++, right? So if I even like glance at the solution, I can't get the answer like right off the bat because I'm coding in Python, and I'm not like I can read C++ obviously, but like I'm not that fluent in it. So it really helps with that, like I guess discipline of looking at the answer, like with like me being much better at Python. Like even if I do look at the C++ solution, I won't like get it right off the bat. Like my for loops don't look like C++ for loops. My the way I split strings is different as well. So yeah, just gonna keep using Python until I can't anymore, basically. Tags, as I said, mostly implementation. If there's one thing that I've been better at, it's implementation. A lot of math, and then greedy brute force. And then as you can see, there's not many like special like data structures on here. There's not really trees and graphs and stuff like that. In the first 100 problems, that's probably to be expected. The easier problems probably don't have complex data structures to work with, right? And then most of my problem solves are like problem A of contest, problem B's. Those are math majority, and then some C, some D. I only solved 3 Ds, so that's interesting to note. And then indexes in contests of problems solved. I guess this is the description of this one. And then ratings of problems solved. Problems without ratings are ignored. Yeah, a lot of my contest problems don't have ratings yet, but okay. Problems appearing on both div 1 and div 2 maybe get counted twice for div 2. Average submissions they had, blah blah blah. Okay, so some maybe to count it twice, basically. So majority 800. It's to be expected. 800s are fast, easy. They're easy for me to do shorts. They're easy for me to just do in my spare time, like in between classes or something. And they were the like majority in that spreadsheet that I showed y'all. So mostly 800s. 900s way less, and that was kind of surprising to me because I've done more 1000s by one problem than 900s, which is good. It's always better to do harder problems. And then 1000 rated, Not much to say, didn't do much of them, or 1100 rated. And then 1200 rated, I've solved the most out of everything except 800s. And then very few 1300, 1400, 1500. Now, I don't really like the skew of this graph. I think 800 should have been lower, like maybe around 20, 30 questions, and then like we'll have 10 more scattered between 1300 and 1000, like around this range here. I would have been much more happy with that. This just tells me I've gotten a little bit complacent, and I've just been doing easy problems to, like, I don't know, satisfy an ego or something. So moving forward, definitely more questions in the 1300 and 1000 through 1300 range. And then what is this? Some numbers about tried 100 problems, solved 100 problems. Average attempts 1.5. Cool to know. Max attempts 5. What is this problem? A contest problem? Cheap travel. Yes, I remember this one. This is the rides one. Interesting. And then solved with one submission, 66 problems. And then max AC accepted. Cool. I don't know why I did that one twice. Number of contests, I did 4 of them. Only went up so far, which is good. And then submissions, doesn't really matter too much. All that matters to me is this big green blob. Looks cool. Now, we can talk about the types of problems I have trouble with, or like patterns I found. And let's start with number 1, min-max abs. So what does that mean? Now, some of these easier problems, like these 800 through even through like 1200 rated problems, they like require an I would say additional dimension of thinking, where like even implementation problems, we'll use this a lot, right? Where it's like you can't just think about the math, like, and I can probably add like modulus in here. Like you can't just think about traditional math where it's like add, subtract, multiplication. Like something you'll use like quite commonly is double divide. So in Python, that just like division to floor. And modulus. Like modulus is like I've been working with it more. Like I'm familiar with it. I know how to use it. That's probably the easiest one to use, in fact. And it's probably one of the easiest ones to be like, oh, I need to use that there. But what's like really not common, or like I found that I'm not like that used to yet, is using max, min, and abs. Like I always try to find this like, if it's a math type of problem, I always try to find this like glorious math solution. Like maybe there's a math solve or a like proof to it. I always try to find this like solution, rather than just I can min max abs it, and the time complexity isn't necessarily like that much slower. So for example, where was the yes, this question, great example. Like you can replace, basically this, what this question is saying is, you're given an array of numbers and you can add like plus and multiplies and parentheses wherever in between it. And I was trying to find like some general formula that will like always solve this problem, like always multiply the 2 biggest numbers, or like add up the smallest, you know what I mean. But like how you actually end up solving this problem, or like the easiest way to solve this problem, is is since there's only three numbers, there's only like so many permutations, right? What you can do is just maximize all the permutations. And like once I figured this out, I just facepalm moment. Uh, you just shove four permutations of the problem into a max function, and you have your answer rather than like trying to solve some complicated math proof where adding the first number to the next biggest number will always give you know what I mean. But yeah, so definitely pay more attention to when I can be using max min abs in problems. And this goes on to number 2. A lot of the problems are find the equation, which is kind of contradictory to what I just talked about. But like the equation, the quote unquote equation in this case, usually has min and max in it. And one of the examples I'll bring out here is war strategy, where if you saw my video on war strategy, the equation contains a max function in it, and that can get kind of complicated sometimes. Like you're usually thinking of an equation in like plus minus multiplication, even modulus maybe, but you don't really think about, oh, I can use absolute value to like cut out some cases here, or I can use max and min to always pick the best case, always pick the most minimal case or maximal case. So equations with max and min, those are very important and very common in these types of questions. Now let's talk about aha moments. And this is what I meant by like, I've definitely gotten better at problem solving. And some of these harder problems I've solved with what I like to call aha moments. Like if it's one of those questions that takes me multiple hours, I'll be thinking about it a lot. I'll be like Googling stuff, talking to friends, and eventually I'll have an aha moment and be like, oh, let's try this. And it kind of works in my favor. Right? And then for the even harder problems, I call it aha moment combining. So a common pattern in the harder problems is it'll be some combination of like you can basically break the problem down into multiple pieces, and we can take a look at I guess is reversal permutation a good example? In fact, I think that the other problem from no, let's not talk about reverse permutation. Let me find the other contest problem. I think that one was much okay. Replace and sum. A better example of like breaking into like you just looking at this code. Block 1, block 2, block 3, right? Like when doing this problem, like say I didn't know each block, that'd be like 3 aha moments. Like aha, I can use a Kermax. Aha, I can keep track of a prefix array to fix my time complexity. Stuff like that. Or like a really good aha moment type question was cyclic merging. This one, like this question was really hard in my opinion, and a lot of things had to go right for it. For example, like aha, I can keep like a subliminal at the end of my max array. Aha, I can use a stack here to keep track of like the conditioning, like basically what's next, and I can pull up this problem. Cyclic merging. Just so y'all know what's going on. Favorites. There we go. Yeah, basically you have a circular array, and you combine like you you're allowed to combine elements, but you always keep the max element. So yeah, like this in itself was an aha moment, and then at the end you have to calculate the cost, which wasn't really an aha moment, but it was like it could have been an aha moment if I like wasn't familiar with how to do it. So yeah, now like this aha moments and like aha moments for these like type of like you can break down into pieces type problems can cause something I call like solution hallucination. Great example of that is actually reverse permutation. Y'all saw me solve this recently, and I don't know what I was on when I was solving this, but I did so much extra to solve this problem, right? And I was talking to my friend about this. I was actually like reviewing this problem in my head, and I couldn't understand like if we're making a submax array, we're taking the maximum of the like we're creating an array where it's a max of indexes, and I was thinking about like this last case where I don't actually check with anything, check the max between anything, and I realized I didn't need to because there's nothing to check with. But like it was just one of those moments where like I think back on my like code slop, and I was like, what is my code actually doing here? Type of like thinking, right? But like I was talking about this problem to my friend, and I was like, wait, I don't even need to do it like this. Like I could just like run one for loop, check until like we hit a number that doesn't fit it, or that isn't the greatest. So in this case, it would be like 4, 3, and then like say I hit like a 1 or something, or I guess it would be 5, 4, and then like say I hit like a 1 or 2. I would just track that index and then keep iterating through. It's just one pass either way until I hit like the greatest number, which would be like the length of the array, right? And then you just track that index, track the index of the number where you first hit, or where you first figured out it wasn't in order, and just swap those. And it would be one pass either way. So I don't know why I like hallucinated up this complicated solution where I track a submax array, like and fill it out from the back, take the maximum of this index and the submax, and then run through the submax and do all these complicated calculations. Not that complicated, but like, you see what I mean? Like the solution could have been so much easier. It would probably be half the lines of code. But like, I guess an aha moment led me a little bit astray, but since it was such an easy problem, it allowed me to solve it. And this could cause problems and harder problems, right? So there's that. And then let's talk about data structures and algorithms. I guess like my formula for like solving these problems, like how I got better at implementation, it kind of follows this order. As you can see, there's not a lot here. These are kind of what I ran into like in these like easier type problems. No like trees, no graphs, like it's just I'm not familiar with those, and that's probably what's holding me back from doing even harder problems too, is like this unfamiliarity with like I haven't sat down and like tried to learn data structures, you know. All I've done is just do problems that might have like a little bit of binary search in it, or might have a little bit of like graphs in it. You know what I mean? So that's definitely something that I'll have to look into doing later on as the problems get harder. But like my step one is always like, can I brute force this problem, right? And can I greedily do this problem? And if I can, it probably just ends up into some like implementation slop. And then it's like, okay, that doesn't work. We can take a look at, does sorting help me here? Does hashing? And hashing should probably come even higher because hashing is like that contains sets and dictionaries and stuff like that. And in my opinion, hashing in itself is like such a low skill floor, high skill ceiling uh, data structure. Because like even recently, I think I did this problem in a video where I ran into a case where it's like, oh, if you change the list in a set and iterate it through, it would be faster than just like iterating through the list. Simply because it's a hashed thing, right? And then just like knowing when to use hashing, like when to use like a dictionary over a list, or like a counter, or all these other like types of data structures, like is a skill in its own. But yeah, and then another thing that's very popular among these lower rated problems are two pointers. So like just seeing if you can look through a list in one pass is very important. And then you run into binary search problems every now and then. Just know the basic implementation with the while loop, find the middle, and then track the left and right. Right. And then you'll have a little bit of DP problems every now and then. DP problems, they're pretty difficult, especially since I'm not that used to the iterative implementation. Like when I learned DP, I always did like the recursive solution, and I've learned that recursion is not really that good in DP problems or in CP problems, just because like you'll run into Stack Overflow, right? And I think there is a workaround for that, but it's just much better. Anything you can write recursively, you can write iteratively, right? So there's that. And yeah, that basically covers everything I wanted to talk about. Like, hopefully that answered some of the questions that I get in the comments about, oh, why use Python over C++? Why are you doing this challenge? Why are you I don't know, how much better did you get in 100 problems? And the TLDR is I'm just getting a little better every day. You know, it's no like sudden jump, especially since I've been focusing on easier problems. I think I'm plateauing to like this like kind of rating level I was even before competitive programming. But I've definitely gotten better because I can do a little more problems now. Like the first contest was I did one problem. The next one I did two. Tried three. Next one, same. Next one I was able to do three. Tried four. You know, so definitely getting a little bit better. Do I think I'm that much better than when I just started? No. But will I be better moving forward? Yes. So, yeah. Wow, this recording has really dragged on, 30 minutes long now. I guess I had a lot to yap about. Y'all will still be getting a daily Codeforces video, so look forward to that later today. But yeah, if you like this video, make sure to like and subscribe, and I'll see y'all guys later.